Hello, this is the first checkpoint examination on the new mathematics code 0862. This is paper 1 of April-May 2023. So the new code is here 0862 and D01 is the first paper. The paper is an R and calculator is not allowed. So if you look at the instruction very well here, you see that the last instruction here, you are not allowed to use a calculator. So this solution will be done without using a calculator. To follow up with my solution, the link to download the paper is in the description section below this video. Download and print it out to enjoy the solution. Let's jump into the questions. Question number 1. A regular polygon has exactly 8 lines of symmetry. Tick this sign to show if these facts about the polygon are true, false, or if you cannot tell. So you need to understand what a regular polygon is. A regular polygon is a shape that has equal sides and equal angles. So for instance, if you have an equilateral triangle, it's a regular polygon because the sides and the angles are equal. Also, a square is a regular polygon because the 4 sides and the 4 angles are equal. So that is the first thing you should take note about a regular polygon. So the next one is lines of symmetry. What is a line of symmetry? A line of symmetry is a line that divides a shape into 2 equal halves, such that when the 2 halves are placed on top one another, so they fit in completely. So that is, there is no space. So that is a line of symmetry. Okay, so for regular polygons, the number of sides is the number of line of symmetry. The number of sides is the number of what? Lines of symmetry. Since we are told that this is a regular polygon and it has 8 lines of symmetry, it means it has 8 equal sides. So if you look at this now, the polygon has 16 sides. So this will be false, because if the regular polygon has 8 lines of symmetry, that implies that it has 8 equal sides. Then the second fact is this: the polygon has rotational symmetry of order 8. So this is true. Another fact about regular polygons is that the number of sides is the same as the number of lines of symmetry and the number of rotational symmetry. So since the polygon has 8 lines of symmetry, so that means the rotational symmetry will also be 8. What is rotational symmetry? So a rotational symmetry is the number of times, is the ability of a shape to look like itself when turned from 0 degree to 360 degrees. So the number of times it looks like itself when turned from 0 degree to 360 degrees is what we call order of rotation. So for any regular polygon, the rotational symmetry, that's the order of rotational symmetry, will be exactly the number of equal sides you have there. If a regular polygon has 8 lines of symmetry, it means that the polygon has 8 sides. It also means that it has 8 order of rotational symmetry. The order of rotational symmetry will be 8. So this will be the solution to question number 1. For question number 2, Carlos rolls a fair 6-sided dice 60 times. The number of trials is equals to 60. We also calculate how many times Carlos should expect to roll a 3. It is 6-sided. That means you have 1, 2, 3, 4, 5, and 6 to be likely shown or displayed. So because it is 6-sided. Now, if it is fair, that means each of these numbers has the same chance of being shown or displayed. Okay, so if you have one now, let's say it is a die, so the number of times it could show if it is rolled once. So the number of time one can show up if it is a dice, okay, it is one. Okay, it is once. Okay, so it can show once. Okay, so now if you want to know the number of times it will show up if you roll the dice 60 times, so that means it will be 1/6 times the number of trials. So this 1/6, it means it can only show once if it is rolled once, right? So then the number of the number of times each of these numbers could show up will be 1/6 times 60, and in this case, if you do that, it's going to be 10 times. Okay, so that means each of these numbers has equal chance of being shown. So 1 can appear 10 times, 2 can appear 10 times, 3 can appear 10 times, 4 can appear 10 times, 5 can appear 10 times, 6 can appear 10 times. Okay, so it's because they all have equal chance of being shown or displayed. Okay, so the answer here, it will be 10 times. Okay, so if you want to get it, just say 1/6 if you have a 6-sided coins, if you have a 6-sided dice. Okay, so it will be 1/6 for anyone to show up, then multiply by the number of trials. Okay, so let's say we have a 4-sided die now. You have 1, you have 2, you have 3, and 4. So if it is rolled 60 times, so what will be the probability, what will be the number of times a 3 can show up? Okay, so it will be, in this case, to be 1/4. Okay, because we have a 4-sided dice. Okay, so times how many times? 60 times, and in this case it will be 15 times. So that means 1 can show up 15 times, 2 can show up 15 times, 3 can show up 15 times, 4 can show up 15 times, and the total will still be, the trial will still be 60 trials. Okay, so for this question we have a 6-sided dice, and that means we have the likely numbers 1, 2, 3, 4, 5, and 6. Okay, anyone could show up by using the probability of 1/6. That is the chance of anyone showing up times the number of trials you have there. It will give you the number of times each of the numbers could show up, since it is a fair dice. Okay, so the answer is 10 times. Let's go to the next question here. Write the letter for each calculation in the correct column of the table. One has been done for you. So if you look at this, the first column we have equal to 7 to the power of 6. Then the second column we have not equal to 7 to the power of 6. So this is 7 times 6. Of course, 7 times 6 is 42. It is not equal to 7 to the power of 6. So what you need to do is to place in the letters here. Let's look into B here. You have 7 to the power of 5 times 7, which is the same thing as 7 to the power of 1. This is multiplication law of indices. You choose one of the bases, then you add the powers. So this will be 7 to the power of 6. Okay, so that means B is equal to 7 to the power of 6. So I'll put B here. Let's check the second one. We have 7 to the power of 6 divided by 7 to the power of 0. In this case, this is division law of indices. So you pick one of the bases, then you subtract the powers, and this will still give us 7 to the power of 6. So that means letter C will also be here. And the last one here is 7 to the power of 2 times 7 to the power of 3. This is multiplication law of indices again. You choose one of the bases, then you add the powers. So this will be 7 to the power of 5, which is not equal to 7 to the power of 6. So that means letter D will be here. Let's jump into the next one. That's question 4. We asked to expand and simplify. So to expand this, you need to use this to multiply the whole of this. Then we also use plus 4 to multiply the whole of this. So that means this will be equals to, you have c into bracket c plus 10. That's the first one. Then we're going to use the second one, which is plus 4. To multiply c plus 10 here. So c times c, that will be c squared, plus c times 10, that will be 10c. So here plus 4 times c, that will be plus 4c. Then plus times plus is plus, then 4 times 10 is 40. So you have expanded the expression. So the next thing is to simplify. So this and this are like times, and then they have similar signs. That means you have to add them together and pick the sign before the numbers. So we are going to have c squared, so plus 10c plus 4c, that will be plus 14c plus 40. So that will be the final answer here. C squared plus 14c plus 40. So it will give us a quadratic expression. So let's jump into the next question. That will be question 5. You're asked to draw a line to match each calculation to its answer. One has been done for you. So if you look at the expressions here, they are all talking about standard form. Let's look into the first one that has been done for us. We have 0.5 divided by 10 to the power of 2. So when you are dividing by power of 10, you shift the decimal point backward according to the number of power there. So here you have 0.5, and then you are dividing by power of 10 to the power, you are dividing by 10 to the power of 2. So that means you have to shift the decimal point backward 2 times, 1 and 2. So that means the decimal point is here. You fill up this with 0. That means you have 0.005. But of course, it is always good to precede a decimal point with a 0. So that means 0.5 divided by 10 to the power of 2 is the same thing as this. So that is very correct. Now let's do the next one. We have 5 times 10 to the power of minus 1. Okay. So in this case, this is the same thing as 5 times 10, 1 over 10. Okay, so it will be equals to 5 over 10. Okay, so we are also dividing by 10. Okay, so that means we need to shift the decimal point to the back. Okay, so this is the same thing as 5.0 divided by 10. Okay, 5 is the same thing as 5.0. So we are dividing by power of 10, which is 1. So we are shifting the decimal point backward once. So that means the decimal point will be here. So we are going to have 0.50. So it is always good to precede a decimal point with a 0. And for a decimal point, you can always neglect the last 0. So that means this is the same thing as 0.5. So this one is the same thing as 0.5. Okay. So the next one there is 0.05 times 10 to the power of 4. If you are multiplying by power of 10, you shift the decimal point forward according to the power there. So you have 0.05 times 10 to the power of 4. So you have to shift the decimal point forward 4 times. So 1, 2, 3, and 4. So that means the decimal point is now here. So we need to fill the empty spaces with zeros. So we are going to have 0, 0, 5, 0, 0, then points. So let's say 0 here. Okay. So you can see that the first 2 0 are useless. Okay. So you can delete them. So that means you have 500.0, which is the same thing as what? 500. So that means the second one is the same thing as this. Then of course the last one should go to this. Okay, So the last one should go to this one, should go to this by default, because that's the only thing you have left. So you can do that to save your time, but we can still confirm our answer. So you have 5 divided by 10 to the power of 3. Okay, so this one is the same thing as 5 divided by 1 over 10 to the power of 3. Okay, so you can do it like this, and by default we have to change this division to multiplication and find the reciprocal of this. Okay, so that means to be 5 times 10 to the power of 3 over 1. Okay, so that means we are multiplying by what? By power of 10 3 times. So we shift the decimal point forward 3 times. 5 is the same thing as 5.0. now if you shift the decimal point forward 3 times, you have 1, 2 and 3. So the decimal point will now be here. You have zeros here, so that means you have 5,000.0, which is 5,000. So that will be the solution. So let's jump into the next one, which is question number 6. So we are asked to work out the value of 10 minus 2x to the power of 4 when x is equals to 4. So in this case, we are going to have open bracket 10 minus 2. So let's substitute the value of x, which is 4 here now. Then everything to the power of 4. So here we are going to have 10 minus 2 times 4 is 8. Everything to the power of 4. Then finally 10 minus 8 is 2. Then to the power of 4. So which is equals to 2 times 2 times 2 times 2 times 2. 2 times 2 4. 4 times 2 8. 8 times 2 16. So that will be your final answer there. So the next one is question number 7. A pyramid has a square base. That means the base here, let's label it A, B, C, D. That is the base. Okay, and it is a square. And the 4, so each side is 10 centimeters. So you have 10 centimeters here. You have 10 centimeters here, and for this one you have 10 centimeters here. So the 4 congruent triangular faces, each with a height of 12 centimeters. So that means the congruent here, it means they have the same area, they are the same. Okay, so calculate the surface area of the pyramid. So to get the surface area of a pyramid, the surface area will be equals to area of the base, which is area of the square, then plus area of the 4 congruent triangles. So that is how to get the area of the pyramid. So a square base pyramid. So now to get the area of the square first, so area of the square will be equals to length times length. So which is what? 10 centimeters times 10 centimeters. In this case, it will be 100 squared centimeter. So this is the area of the base, okay, which is area of a square. So next is to calculate the area of a face of a triangle. Then we multiply it by 4, since all the 4 triangles are congruent. That means they have the same area. So the area of a triangle will be equals to base times height over 2. So in this case, the base is what? Is a side of a square. So which should be 10 centimeters times the height. The height is 12 centimeters, okay, as given, then over 2. So 2 here, 1, 2 in 12, 6 centimeters, 6 centimeters times 10 centimeters. So that will be 60 squared centimeter. So that is area of a triangle. Okay, that is one. So we have 4 of them. So the area of the 4 triangles so be equals to 4 times 60 centimeters squared. So that will be 240 centimeters squared. So the area of the 4, so I can write it here, 240 centimeters squared. So this will be the area of the 4 congruent triangles. Okay, so now the area of the pyramid will be area of the square plus area of the 4 congruent triangles. The area of the square is already 100 centimeters squared. So if you have everything together, so this will give us 340 squared centimeter. So that will be the area of the pyramid. So let me have a space here. So it will be 340 centimeters squared. That is the area of a pyramid. So to get area of any pyramid, it will be the area of the face it will be, to get the area of any pyramid, the formula will be the area of the base, okay, plus area of the 4 faces, okay, area of the 4 triangular faces. So let's go to the next one. Here the arrow points to a number, and here you can see that this is very close to 5.5. okay, here is very close to 5.5, very close to that. So this is 5.4 something here. Okay, so draw a ring around the number the arrow points to. So this is root 11. Root 11 will give us 3 point something. Okay, so it will give us 3 point something. So this is very far from 5.5 5.5. Okay, so the next one is root 22. Root 22 will give us 4 point something. Okay, so which is also a little bit far from 5.5. So 30 will give us 5 point something, right? So which is very close to 5.5. okay, and root 35 is very close to root 36. okay, that will be like root 36 is 6 times 6, it will be, so this is very close to 6. okay, so root 35 is very close to 6. Why? Because root 36 is 6. okay, root 36 is 6. So root 35 is very close to root 36, which is 6. So that means this one is very close to 6. okay, so the one that is correct answer here, it is root 30, because root 30 is very close to 5.5. so I'm going to circle this. This will be my answer. Okay, so the next one is question 9. Ahmed draws this graph to show how the number of visitors to his town has increased. So big increase in the number of visitors to the town. So by the vertical by the right hand side here, okay, the vertical axis here, we have the number of visitors, but for the horizontal axis, so it is not labeled here. So we also give one reason why the graph could be misleading. So the graph could be misleading due to the following. You can say the graph isn't labeled properly, so that can be your answer. So the graph, can say the graph isn't labeled properly. Okay, so another thing you could say is that the scale is not shown. Okay, so you can see here for the vertical axis here, so the scale is not shown, and for the horizontal axis here, okay, so the scale is not shown. So another reason you could give is that the scale is not shown. So you just need any of this following. The scale is not shown. So the scale is not shown. So here another thing you could say is that the curve has different thickness. You can see here, look at the thickness of the curve here compared to the other side here is becoming thinner and thinner. Okay, so this could also be misleading. Okay, so anytime if you want to determine if a graph will be misleading, you can trace it to the labeling of the axis. Then you can also trace it to the scale of the axis as well. Okay, so these are the three things you could say about this. The graph is not labeled properly, the scale is not shown, and if you look at the curve itself, so the thickness varies. Okay, so you can give any of these three as your reason. You just need only one. So the next question is question number 10. 1/n is equivalent to recurring decimal. Yes, n is a whole number. Safia says n must be greater than 5. Write a number to complete this sentence. Safia is not correct because the value of n could be, okay, if you have 1 out of n now, so the value can also be 1 out of 3, because if you convert this to decimal, 3 goes in 1, you have 0. Okay, point, you add 0 here, you have 10. 3 goes in 10, you have 3, remainder 1. You add 0 again, you are back to 10. So 3 goes in 10, you have 3, remainder 1, you add 0. So you keep on having this. Okay, so that means the value of n could also be 3, and 1/3 is a recurring decimal number. So the next one is to write 70,000 in standard form. To write a number in standard form, the number must be of this form: a times 10 to the power of n. So where a is a number between 1 and 10, it cannot be less than 1 and it cannot be up to 10. So that is the value of your a here, and your n could either be positive or negative. Now, so a here is the standard form number. So let's see, I need to get my standard form number. So you have 70,000 here, and don't forget that my standard form number must be between 1 and 10. It cannot be less than 1 and it cannot be up to 10. So if I put it here, so it will give me 7,000. It can't be there. If I put the decimal point here, it will give me 700. It cannot be there. If I put it here, it will give me 70. It cannot be there. So if I put it here, it will give me 7.0. So this 7.0 meets the criteria of a standard form number. It must be between 1 and 10. So 7.0. So if I put it here, don't forget that there is point here now. Okay, so that is 70,000. By default, there is a point here. Okay, so now I have inserted my point where now? Here. So I will count from where I inserted my point to the point that comes with the question. That means I have 1, 2, 3, and 4 here. That is moving forward. That is plus 4. So it will be times 10 to the power of positive 4, which is same thing as 4. So this is how to write a number in standard form. So this one here is your standard form number, which must be between 1 and 0, where the number cannot go below 1 and it cannot be up to 10. So that is the solution to that question. 11b, you are asked to write 7.5 times 10 to the power of -3 as an ordinary number. So if you look at this number here, 7.5 times 10 to the power of -3. So 7.5 is a standard form number. Okay, so if you have times 10 to the power of -3, that means you have to count our decimal number backward 3 times to have the ordinary form of the number. So from here, you shift it here. Why am I going back? Because of this -3 here. So to be 1, 2, and 3. So that means the decimal point is here. You can now fill up the empty spaces with 0. That means I'm going to have 0.0075 and then that's 75. Okay, so it is always good to always precede your decimal point with a 0. So this will be the correct answer. So the next one is question 12. Here is Eva's method for drawing the perpendicular bisector of the line AB here. So she draws an arc, radius 5 centimeters, center A. That means she puts a pair of compasses at point A and she open it up to 5 centimeters and drill this arc here. Okay, then she draws an arc, radius 6 centimeters, radius 6 centimeters, center B. So she also put the a pair of compasses at B and measured 6 centimeters and also drew this arc again. She draws a line to connect the point where our arcs intersect. So we are asked to explain why Eva's method is not correct. So our method is not correct is because let's write here, she uses different radii from points A and B, and or you can say the 2 points and the 2 points are not equidistant from the center. Okay, so you can say because the 2 points are not equidistant from the center. Okay, because a perpendicular bisector divides A and B into 2 equal halves. That means the line, the perpendicular bisector must pass through the center of A and B. So since she didn't use the same radii, then since she does not have equal distance between A and B, that means the method is very wrong. Question number 13. Here is a formula: y equals to root w minus 2, and you are asked to draw a ring around the correct rearrangement of the formula. If you look at the options, here we want to make w the subject of the formula. That is, you want w to stand alone. So to do so, you can write the expression, the equation given to us: y equals to w minus 2. Now to do this, you have to take square of both sides. You have to square both sides. So this one will be like this. Okay, square, we cancel the square root here. So we have y squared equals to w minus 2. Okay, so since you want w to stand alone, that means minus 2 has to come to this side, and when it leaves the right hand side for the left hand side, the sign changes to positive. So that means I have y squared plus 2 is equals to w, which is same thing as w equals to y squared plus 2. So which one is the correct one? W equals to y squared plus 2. So this is the correct option here. So the next one is question 14a. You are asked to write down the value of this: 7 over 3 times 5 times 3 over 7. So to do this, you can say 3 cancel 3, 3 here 1, 3 here 1, 7 here 1, 7 here 1. So we are left with 1 by 5 by 1 over 1 by 1, and everything will still give us what? 5 over 1, which is same thing as 5. So the correct answer here is 5. Let's go to question 14b. Calculate 9 out of 10 divided by 2 whole number 2 out of 5. So if you do this here, you have 9 over 10. So divided by, let's write that mixed number as an improper fraction. 5 multiplied by these 2, that will be 10. 10 plus the numerator, which is 2. So 10 plus 2, you have 12 over 5. So now what you need to do is to say 9 out of 10 we change this division to multiplication. Then we take the reciprocal of 12 over 5, which is 5 over 12. So you can say 5 goes here once, 5 goes here 2 times, 5 goes 3 goes in 9 3 times, 3 goes in 12 4 times. We are left with 3 times 1 over 2 times 4. So here you have 3 times 1 3 over 2 times 4 8. Okay, so the simplest form is 3 out of 8. We have question 15. The internal storages of 3 games consoles are 500,000 megabytes, 32 gigabytes, and 1 terabyte. Write these values in order of size, starting with the smallest. You know, the smallest one, if you look at the arrangement of the sizes, so the smallest one is megabytes, followed by gigabyte, and followed by terabyte, and followed by terabyte. Okay, so you know that 1000 megabytes will give us 1 gigabyte, and 1000 gigabytes will give us 1 terabyte. Okay, so if you look at this one now, for you to compare them, 500,000 megabytes, 32 gigabytes, 1 terabyte. So for you to compare them, they must be in the same unit. So let's express everything in megabyte. So we already have this one to be 500,000 megabytes. So 32 gigabytes will be 32 times 1000. So that will be 32,000 megabytes. That's MB. So to convert 1 terabyte to megabyte, you have to say 1 times 1000. So that will be gigabyte. So because if you multiply by 1000, it will be in gigabyte. So if you multiply by another 1000, then it will now be in megabyte. So times another 1000, so it will be in megabyte now. So that means we have 500,000 megabytes. The next one is 32,000 megabytes, and then the last one is 1 million megabytes. So they are all in the same unit now. So if you look at the smallest one there, it will be 32,000 megabytes, which is for this 32 gigabytes. So that means the smallest one will be 32 gigabytes because it is 32,000 megabytes. Followed by the next one, it will be 500,000 megabytes, and the largest will be 1 million megabytes, which is for 1 terabyte. So that is how to arrange that. Hello, before you is question 16, and it is on transformation. In this question, we are asked to do transformation of triangle T, and in this case, it is rotation. Rotation is best done when you have a tracing paper, but if you don't have a tracing paper, how are you going to do the rotation and you are going to have a good result? So there is another way you can do rotation if you don't have a tracing paper. All what you need to have is your protractor and a ruler. So that is what you need to do. So let me show you how you make use of a protractor and a ruler to rotate a given shape. Okay, so question 16a, triangle T, this triangle here, triangle T is rotated by 180 degrees about center 0, 0. That is about the origin. So that's the first thing we're going to do. We are going to rotate this triangle T by 180 degrees about the origin. Then that will give us a new triangle. Then the new triangle is then rotated again by 180 degrees about center 0, -3 to give triangle U. So that is the image of the second transformation, and we are asked to draw the position of triangle U on the grid. So what we need to do is that we need to rotate this triangle T 2 times. The first one is by 180 degrees about the origin. The second one is that the new triangle, that is the image of T, the image of triangle T, which is a new triangle now, we are still going to rotate it again by 180 degrees about a new center, which is 0, -3, and that second image will be named triangle U. So that's what we want to do now. So what you need to do is that you take your ruler, okay? So from my center of origin, in this case now, the center of origin here, from my center of rotation, which is the origin in this case, so I have to draw a line to each of the vertex of triangle T. But the first thing is to label the vertices. So this will be A, this one will be B, and this one will be C. Okay, so I've labeled the 3 points, the 3 vertices of this triangle T. So now, how am I going to use a protractor to rotate this by 180 degrees about the center of rotation, which is the origin? So let's draw a line from point A to the center of rotation, which is the origin now. Okay, so that's the first step. So the next thing we need to do is to place the center of this protractor at the center of rotation, and the line, which is the line that goes to point A, must be on 0 degree. So you take your time and set it very well. Okay, once you make sure that 0 degree is on point A and the center of the protractor is on the center of rotation. Okay, so let's move from 0 degree here and go to 180 degrees to get the direction of 180 degrees. So if you come here, you go through this side here and come to this place. So this will be the location of your 180 degrees. Okay, so I have inserted a point here. That is the direction of 180 degrees. So I will remove the protractor, then I will draw a line from point A to center of rotation. Let me measure it from A to center of rotation. It is about 2.2. Okay, so for my center of rotation, I will set it very well so that the ruler will be in line with the point I inserted here. This point, don't forget that it is to indicate, to get the direction of my 180 degrees. So if I measure 2.2 now, it will be somewhere around here now. Okay, I have set my ruler very well so that it is passing through the 180 degrees here. So 2.2 will be here. Okay, so this is my A prime. So let me call this A prime. Okay, so I got that point now. So this particular point here where my pencil is my A prime. So this is my A prime. This particular spot here where my pencil is my A prime. So the next thing is that I'll see draw a line from the center of rotation to point B to get B prime. But fortunately for us, it is still in the same line as this one here. Okay, so I don't need to draw another one here. So I'll just measure from point B to my center of rotation. It is about 4.2. Okay, for my center of rotation now, I will place the ruler here and it must be in line with this dot here. Remember, this dot is to get the direction of 180 degrees. Where my pencil is now, there's a point there. That point is what I used to measure. I measured out from the protractor to know the direction of 180 degrees. Okay, so for my center of origin, so I'll measure another line which is about 4.2. In this case, it is this point here. Okay, it is this point here. So I will call this point B prime. So I'll name it B prime. So that's my second point. I have 2 points now. Okay, so the last one here is to draw a line from point C to my center of rotation here. Okay, so I'll draw a line here like this. That's the line. Okay, then I'll now place my protractor to get the direction of 180 degrees. So the center of the protractor will be on my center of rotation. Then 0 degree will be on point C like this. I'll set it very well. So once I set it very well, then I can now measure 180 degrees. So I'll set it very well now. So this is 0. You come like this up to this point here, and this will be the direction of what? 180 degrees here. Okay, so I'll put it there. Now I'll place my ruler there. I have to measure from point C to the center of rotation. If you place it very well, and that will give you about 4.2 again, to give you about 4.1 thereabouts. Okay, 4.1. So I'll place the ruler again at my center of origin, and it must be in line with this point here. Okay, it must be in line with that point, and I'll measure about 4.2 again, so it must be in line with this. Okay, so 4.2 in this case now will be somewhere around here. Okay, 4.2 is somewhere around here. So that is where my point will be here. So let me label it. So this will be point C prime now. Okay, so I have my 3 points now. So I have A prime, B prime, and C prime. So let me join A and B prime together. So I'm joining them like this. Okay, then I have to join B prime and C prime again here. So I'll join them like this. Then finally I'll join A prime and C prime together. So place it here and place this one here. Okay, so this is a new triangle called T prime. So this is the rotation of triangle T by 180 degrees about the origin. So I've done the first part. So the second part is to rotate this T prime by 180 degrees about the center 0, -3, which is this point. So I'm going to repeat the same steps. So let's take the first one now, which is A prime. So let's draw a line from our new center of rotation to point A1 here and to A prime here. Okay, then I'll place my protractor. The center of the protractor will be the on center of rotation, and 0 degree will be on A prime. Okay, so when I set that very well, then I can easily get the 180 degrees. This is 0. Okay, you come the long way around here, and this will be the direction of 180 degrees. Okay, so when you do this now, then you now take your ruler from point A prime to center of rotation here. This is about 1.2 here. Okay, then I will now measure the same thing from my center of rotation here. For my center of rotation, I will set the ruler to be in line with this point. Remember, this point is to get the direction of 180 degrees. Okay, so then let's measure 1.1 here. If you set it very well, okay, so you see that it will be 1.1 will be around here. Set it very well. So 1.1 will be around here if you set it very well. So it will be here. So it will be here. So I can call this A prime prime. So let's name this A prime prime. Okay, so the next thing is to draw a line from B prime to my center of rotation. Okay, so let's draw another line there. Okay, we have done that. Then the next thing we need to do is to take the ruler and measure the distance between the center of rotation and B prime. So this is about 1.1. Then okay, so now let's place the protractor here. We need to get the direction of 180 degrees. Center at the center of the protractor on the center of rotation. Then 0 degree will be on C prime. Okay, then let's measure from here 0 to 180. This is 0. Then it comes up here. Okay, so this will be the direction of 180 degrees here. So this is the point here to measure that. So let's measure from the center of rotation. We place the ruler, so it must be in line with this point here. This point is to take note of what? The 180 degree, the direction of 180. Okay, if you do this, okay, you place it here, or you can place here. So I'm on center of rotation, and it's in line with that point that I inserted to indicate the what? The direction of 180 degrees. So I have to get 1 point. I have to get 1.1. So place it very well. Then 1 point. So I'll take my ruler, I'll put it on the center of rotation and measure the distance between the center of rotation and point B prime. This is about 2.1. Then now I'll place the ruler again on my center of rotation, and it must be in line with the point I inserted here. Remember, this point is to get the direction of 180 degrees, and I'll measure 2.1 again, about that. So 2.1 is around here. When you place it very well, it's around here. So this is the point here. So it will be this will be B prime prime. That is the image of B prime. So B prime prime. And the last one is to draw a line from point C to my center of rotation. Okay, so if you draw another line there, so it will be this. Okay, then you take the protractor there to get the direction of 180 degrees. The center of the protractor will be on the center of rotation, and 0 degree will be on C prime. If you set it very well, okay, so from C, that is 0, you come all the way here, and 180 degrees is somewhere here. Okay, then I'll remove my protractor, then place my ruler from point C to center of rotation is about 4.2. Then from my center of rotation, I'll place the ruler, and it must be in line with this point here. This is what I will use to get the direction of my 180 degrees. So we measure about 4.2 again, and if you trace it very well, okay, it is about this point here. Okay, so it will be here. So this point here is my C prime prime. That's the image of the C prime. So I need to join them together. So from A prime prime to B prime prime, I will join them together like this. Then from B prime prime to C prime prime, I also join them together like this. Okay, then finally I will join A prime prime and C prime prime together. Okay, so if you do that, this is what you are going to get. Okay, so this is the image of T prime, which we are asked to name U. So this is triangle U. Okay, so this has been done. Okay, so the last thing we need to do, that's the B part. We also draw a ring around the type of transformation that maps triangle T, that is, that maps this onto this. If you look at it very well, they are on the same line. That is, A is in line with A prime prime, B is in line with B prime prime, C is in line with C prime prime. Okay, so this is translation. That means this one was translated, triangle T was translated downward to get triangle U. So from each of the points to the image, we must get the same distance. Let's count from A to A prime prime. 1, 2, 3, 4, 5, 6. So let's count from B to B prime prime. 1, 2, 3, 4, 5, and 6. Let's count from C to C prime prime. 1, 2, 3, 4, 5, 6. That means it is translation by x equals to 0 and y is equals to 6. That is 0, 6, like this. So this is how the translation was done. So we are going to circle the correct transformation now, and in this case it is so in this case it is this now. So it is translation. That is the transformation that maps triangle T onto triangle U. It is translation. The next one here is question 17a. The table shows information about the masses of 70 boxes. Okay, here you are asked to draw a ring around the interval that contains the median. So for you to know the median, you need to add a column here, and you can call this column cumulative frequency. Okay, that's CF for cumulative frequency. So how do we get this? It's very simple. So we are going to write down the first frequency, which is 10. So 10 add 7, that will be 17. 17 add 13, that will be 30. 30 add 20, that will be 50. 50 add 20, that will be 70. So this is how to get the cumulative frequency. So we have our n to be, that summation of the frequencies to be 70. So the median class will be 70 divided by 2, that will be 35th. Okay, so that is the median class. So 35th will be under which cumulative frequency? It will be under here. So that means the median class will be here. So that is 20, between 20 and 22. So this will be the correct option here. So that is the median class. So let's go to the next one. That's the B part. We are asked to draw a frequency polygon to show the formation in the table. So let me draw the frequency here. So we have the masses and the frequencies here. Okay, so to draw the frequency polygon here, we have two options. So we can firstly draw the bar chart, then we'll now find the midpoint, then we will need to connect all the midpoints together, and you can easily find the midpoint here without drawing the bar charts. So you can just find the midpoint now, and we now link all the points together. So you can draw it with the bar chart and without the bar chart. So I want to draw the frequency polygon without the bar chart. So I need to find the class mark. Okay, so the class mark is the middle number. So to get the class mark, you have to add these two numbers here, the lower and the upper limit here, and divide by 2. 14 plus 16, okay, divided by 2, so that will give you 15 here. So 16 plus 18 divided by 2, so it will give you 17. You can see the number is in between 14 and 16 here, which is 15. The number is between 16 and 18 here, which is 17. So for the third one, the number between 18 and 20, that will be 19. That's another way of getting it. Or you add the two numbers and divide by 2. So this one will be 21 and this one will be 23. Okay, so to get the point now, so let's plot this on this grid. So when the class mark is 15, so for this one, what is the frequency? The frequency is 10. So I can mark this point here. Okay, so when the class mark is 17, so what is the frequency? The frequency is 7. 17, the frequency is 7. So it will be the middle here. Okay, the middle here. So when the class mark is 19, the frequency is 13. So 13 will be the middle here. So when the class mark is 21, so 21, then the frequency is 20. So 21 and then the frequency is 20. It will be this point here. So the last one here, when the class mark is 23, so the frequency is also 20. So 23, let's raise it up here. So it will still be the same level as this. Okay, so what is a frequency polygon? So what is a polygon? A polygon must be a closed figure. Okay, so if you join this line together now, the first one will be this. So now let's join the point together from here to here, up here, up here, and up here. So this is what we have, but we are not done. A polygon must be a closed shape. So that means at the beginning, we have to find the midpoint here at the beginning and close it. And for at the end, we have to do the same thing. So let's look for a range at the beginning. So before 14 and 16 here, we should have a range there. And the range should be between 12 less than or equals to x, and x is less than 14. So that the middle number there will be 13. And here the frequency will be what? 0. So that means there should be another point here. So when it is 13, the frequency is what? 0. Okay, so after 22 and then 24, there should be another range there. It will be 24 less than or equals to x, and x less than 26. So that the middle number will now be 25 here. And the frequency will be 0. So that means there should be another point here. Okay, so let's join this 13 to this first one here, and let's join this one to the last one here to have a closed shape, which is our polygon. So this is the required frequency polygon. So you can see that it is now closed here. Okay, it is closed here. So if you shade it very well, what we have inside this now, so is our frequency polygon. Everything you have inside here, so that is the frequency polygon. It must be a closed shape. So everything you have inside here, that is the required frequency polygon. Let's go to the next one. That will be question 18 here. So the nth term of a sequence is n squared plus 5. Find the seventh term of the sequence. So the nth term is written as this: n squared plus 5. So we want to find the seventh term. So that means n is equals to 7. That's the meaning of the seventh term. you're going to have 7th equals to 7 squared plus 5. So this will be 7 times 7. That will be 49 plus 5. So if you add these together, this is going to give you what? 54. So that means the 7th term of the sequence is 54. Question 18b. Here are the first 5 terms of a difference sequence. You have 0, you have 3, you have 8, you have 15 and 24. Find an expression for the nth term of this sequence. Which type of sequence is this? So let's firstly write it here. You have 0, you have 3, you have 8, you have 15 and you have 24. So let's see the difference here. This will give you 3 minus 0, 3. This and this, it will give you 8 minus 3, 5. This and this, 15 minus 8, 7. This minus this, we are going to have what? We are going to have 9. You can see that this is the first difference, and at first difference we don't have common difference. We don't. So let's find another difference again. 5 minus 3, you have 2. 7 minus 5, you have 2. 9 minus 7, you have 2. So this one here is the second difference. So at the second difference, we have common difference. Our common difference is what? Is 2. So let's say the common difference is equals to 2. So since we have common difference at the second difference, that means this is what? This is a quadratic sequence. So a quadratic sequence will always give you common difference at the second difference. So it is a quadratic sequence. So how do we find the nth term? It's very simple. So the first thing you need to do is to divide your common difference by 2 and multiply it by n squared. So that is the first step. So my common difference is 2. If I divide it by 2, anything your common difference is, you always divide it by 2 and multiply by n squared. So this will give me n squared. So that means part of my answer is already n squared. Now, so don't forget that this is my original sequence here. So I can write it here. The original sequence, let me write it here. So it will be 0, 3, 8, 15 and 24. Now I have n squared as part of my nth term for the sequence. Now I'll use this n squared to form another sequence. So when n equals to 1, I have 1 times 1, that is 1. When n is 2, I have 2 times 2, that is 4. When n is 3, for the third term, 3 times 3, 9. When n is 4, 4 times 4, 16. When n is 5, 5 times 5, 25. So I have to subtract this. Okay, I have to take this one is my new sequence. Okay, I have to take away my new sequence from the original sequence. That is, I have to say original sequence minus the new sequence. 0 minus 1, this will give me minus 1. 3 minus 4, this will give me minus 1. 8 minus 9, this will give me minus 1. 15 minus 16, minus 1. 24 minus 25, minus 1. So since I have minus 1 all through, that means I will just add it to this. That is n squared plus minus 1, which is the same thing as n squared minus 1. So it is n squared minus 1. So that is the n term of the sequence. Okay, so you can see my video later on my channel. I will make a comprehensive video regarding sequence where this will be fully discussed. So this is the end term of this sequence. So you can confirm it. You can check your answer by using this now. So this one is the first term, that is 0. So let's put it here. When n is equals to 1, you have 1 squared. 1 times 1, 1. 1 minus 1, 0. You can see it will give us this. So this is the second term, that is n equals to 2. 2 times 2, 4. 4 minus 1, 3. So our answer is correct. Okay. So the next one here is 8. That's when n equals to 3. 3 times 3, 9. 9 minus 1, you have 8 here. Okay, so this is how you get all the terms. Okay, so that means this is our nth term for that sequence. So the next one is question 19. Find the coordinate of 2 points on the line y equals to 5 minus 3x, which have a negative x coordinate and a y coordinate which is a multiple of 4. So from this condition now, that means your x must be a negative number or negative integer. Sorry. So from these conditions, that means x must always be a negative value. Okay, it must always be negative, and y must be a multiple of what? 4. That is, you can have 4, 8, 12, 16, 20, and so on and so forth. So this is what your coordinates should look like. Okay, so what we're going to do is that we'll test it with the value of x, which is a negative 1. Then we proceed from there. Okay, so let's say when x is equals to minus 1. So let's see. So this one meets the criteria for the x coordinate. It is negative 1. Let's see if it will give us the value of y, which is a multiple of 4. So it will be y is equals to 5 minus 3 into minus 1. So this will be 5 minus times minus, similar signs combined together to become positive. 3 times 1, 3. You can check my YouTube channel where I discuss addition, multiplication, division, and subtraction of integers for year 8. I have 7 videos there. Okay, so here this is 8. So that means this one is correct. Now when x equals to minus 1, that's a negative value, then the y coordinate is 8, which is what? A multiple of 4. So that is the first one. Let's see what will happen if x is equals to negative 2. That means y will be equals to 5 minus 3 into minus 2. So this will give us 5 plus 6, which is 11. 11 is not a multiple of 4. We leave it. When x equals to negative 3, so you have y equals to 5 minus 3 into minus 3. So this will give us this will be equals to 5 plus 9, and that is 14. Also 14 is not a multiple of 4. We leave it. So let's go to when x equals to negative 4. So we have y to be equals to 5 minus 3 into negative 4. This will give us 5 plus 12, and that will be 17. 17 is not a multiple of 4, so we can't use it. Let's use when x equals to negative 5. So we are going to have y equals to 5 minus 3 into negative 5. So this will give us 5 plus 15, and that will give us 20. So 20 is a multiple of 4. So that means it meets the criteria. We're going to have negative 4 and 20 here. So these are the coordinates of x and y that meet the condition given up here. So let's go to the next question. That's question number 20. Chen records the length in millimeters of 10 shells. Okay, these are the length of the shells. Then it draws this stem and leaf diagram to show the data. Chen's stem and leaf diagram contains some errors. So you are asked to draw a correct stem and leaf diagram to show Chen's data. If you look at it very well, stem and leaf diagram is not well arranged. Okay, So you should start with 3 followed by 4 followed by 5 and 6. So that is the error there. So it's supposed to be 3 up here followed by 4 followed by 5 followed by 6. Then if you now fill in that very well, you should have 1 here for 31, 4 here for 34, 7 here for 37, 8 here for 38. So you can just quickly complete the remaining ones. So the only errors there is the arrangement. So if you arrange very well, so this is what we're going to have. So this is the correct way Chen should have arranged the stem and leaf diagram. So the next one is question 21. Here the diagram shows a rectangle ABCD. So if you have a rectangle ABCD, that means the opposite sides are parallel, you know that, and then each of these angles will be 90 degrees. So this one too will be 90 degrees. So this one here will also be 90 degrees, and this one here will also be 90 degrees. That's one of the properties of a rectangle. Each of the angles is what? Is 90 degrees. Okay, so EF is parallel to AB. Where is AB? So this and this, EF and AB. So this line, these lines EF and AB are parallel. Okay, then also we are told that EG is parallel to HF. EG, so this is EG, it has been indicated. So I can use two double symbol for this, okay, because EG is already marked this, and then HF is already marked this. So to differentiate them, so this is what we have here. So we want to find the value of X here. So you need to take note of some things. Since AB and EF are parallel, and we already know that AB and CD are also parallel because opposite sides of a rectangle are parallel. So that means this one to CD will also be parallel to this. Now what we need to do is to calculate the size of the angle marked S. So if you look at this diagram, let me trace it here. So starting from E, so let's go to G. Okay, so let's go to, from G, let's go to H here. Then from H, let's go to F. We have letter Z. So that means this angle 46 degrees and this angle here will be what? They will be alternate angles. So this will also be 46 degrees. Why am I doing this? It's because I want to find the value of X. Once I know this angle here, this angle here, and I can easily find the value of X because the three angles must add up to 180 degrees. So that is why I have to find this one. So next is to find this angle here. This angle here. So let me find it. Okay, to do that, so I already know that this one is 20 degrees. This one is 90 degrees. So automatically the angle here will be what? It will be 70 degrees because the three angles must also add up to 180 degrees, and this one has already taken 90 degrees. That means this angle and this angle must add up to 90 degrees, and this one has already taken 20 degrees. Then the remaining 70 degrees will be for this. Now if you look at this very well, so I want to get another alternate angles here. So what am I going to do is here. So let's look at this from this line here. Let me draw the line. You see, from here to F, then from F let's trace it down to H. So from H let's trace it down to C. You see that this angle 70 degree at H and this angle that I marked here, they are also in letter Z. That means they are alternate angles and they are what? They are equal. So that means this place will also be 70 degrees. So I can now find the value of my X because X plus 70 plus 46 will add up to what? 180 degrees. So I'll say X plus 70 degrees plus 46 degrees equals to 180 degrees. That is sum of angles in a triangle. So these two will surely add up to 116. If you do that, x plus 116 degrees equals to 180 degrees. So let's collect like time. This one goes there and becomes negative 116 degrees. I have x equals to 180 degrees minus 116 degrees, and x is equals to what? X is equals to 64 degrees. So that will be the value of my x there. That is pretty simple. So let's go to the next one. This is question 22. Okay, so Lily hit the water in a swimming pool. The graph shows the temperature in degrees Celsius of the water for the first 50 minutes after 9 a.m. So this one is for the temperatures, and this one here, the horizontal, is for the timing after 9 a.m. So here we are asked to find the temperature of the water. Okay, the temperature of the water continues to increase at this constant rate. Find the temperature of the water at 11 a.m. So this is pretty simple. What we need to do is just to look at where we can have the minute and the corresponding temperature. So let's look at 20 up here. So if you trace 20 up here, you can see that this is 9:20. So by 9:20 a.m., so the temperature is what? If you trace it here, is 16.4 degrees Celsius. So let's see, another 20 minutes, that will be 9:40 here. So another 20 minutes, that will be 9:40 here. If you look at it, let's trace it to the temperature. You see that it is 16.7. So by 9:40 a.m., okay, the temperature is now 16.7 degrees Celsius. So if you look at it, you see that every 20 minutes the difference is always what? The difference is always 0.3, because if you do 16.7 degrees, so let me do it here, 16.7 degrees minus 16.4 degrees, so this will give you 3.0. So that means you always have 0.3 degree Celsius after 20 minutes. So you cannot do that. After 9:40, the next one will be another 20 minutes. After 9:40, so another 20 minutes will be 10 o'clock a.m. So we're going to get the time. So the next one after 10 o'clock will be 10:20. That's another 20 minutes, 10:20 a.m. So another 20 minutes will be 10:40 a.m. and another 20 minutes will be 11 o'clock a.m. So this is what we want to get now. Okay, so let's see. So the difference is already 0.3 degrees Celsius after each 20 minutes. So if you add 0.3 to this one, it's going to be 16.3. So that will be it will be 16.7 plus 0.3. If you add this, you have 0, keep 1, that's 17.0. So you're going to have 17.0 degrees Celsius here. So for this one, it will be 17.0 plus 0.3. It will be 17.3 degrees Celsius. For this one, we are going to add 0.3 again. It will be 17.6 degrees Celsius. If you add 0.3 again, it will be 17.9 degrees Celsius. So that means the temperature of the water at 11 a.m. will be 17.9 degrees Celsius. So that is the final answer. So let's go to the next question. The next question, that's question number 23. So Oliver and Angelique each have a jar that contains only green counters and red counters. Okay, so the total number of counters for Oliver is 42 in the ratio 3:4, while the total number of counters for Angelic is not given, but the ratio is 5:2. And we are also told that Angelic has the same number of red counters as Oliver. Find the total number of counters in Angelic's jar. Okay, so what we need to do here is very simple. Okay, so for Oliver, so we have the we have green. Let me do it here. Green ratio red. So we have 3:4. Okay, so and they are sharing what? They are sharing 42. So we need to find the number of rounds they will go. Okay, since they have she has a total of 42. Okay, and each round they must both pick 7. So that means we are going to have 42 divided by 7. That is 6 times. So that means they are going to go 6 times. Okay, so if they go 6 times, that means the green will be 6 times 3. It will be 18 green, and then the red will be 4 times 6. That will be 24. So this is for Oliver. Now we can now use this to calculate Angelic. Okay, so I can do this now. So for Angelic here, so we have the green ratio the red. Okay, so in the ratio 5:2. Okay, but we have been told that Angelic has the same number of red counters as Oliver. So that means the red will also be 24 here. So it is now easy for us to get, excuse me. So with this 24 now, so we know how we can get 24 here. So we can use that to get the answer for the green too. So if you have 2:2 and it's now 24, that means you have times 12. So you are going to have times 12 here. So this will also be 60. Okay, you can see that for Oliver, if you add 18 to 24, that must give you 42. That's the total number of counters. So for Angelic, you must add 24 to 60. So that will give you 24 and 60 together. So that will give you the total number of counters for Angelic. So that will be 60 plus 24. That will be 84. So that means Angelic has 84 counters. So the total number of counters in Angelic's jar is 84. So the next question is the 24th one. The area of a trapezium is 24.5 centimeters squared, and we have the diagram here, not drawn to scale. Then A, B, and H are integers greater than 1. That means A, B, and H could be we start from 2 upward. And another thing is that A is always less than B. Of course, you can see from the diagram that the B value is always bigger than the A value. Okay, so find a set of possible values for A, B, and H. So to do this is very simple. The diagram is a trapezium, and already we know that the area of a trapezium is A add B times H over 2. Okay, in this case the area is given as 24.5 square centimeter. So it's equals to A add B times H over 2. So if you cross multiply, you're going to see that 24.5 times 2, you can do it up here. 24.5 times 2, 2 times 5, 10, you write 0, you keep 1. Then 2 times 4, 8 plus 1. that is 9. Then 2 times 2, 4. You have 1 decimal place in the question, so we're going to count 1 decimal place here. So that means if you cross multiply, 24.5 times 2 will be 49. Then it's equals to a plus b multiplied by h. Okay, so from here, what we notice is that if you add a to b and multiply it by h, you must get 49. So now this is our guide now. So we need numbers that multiply two numbers, that is a plus b, that is one number, then h is another number. So these two numbers must multiply together and give what? 49. So we have 1 times 49 to give 49, and we have 7 times 7. Fine. So of course 1 times 49 is out of it because none of these values could be 1. So this one is out. So we have 7 times 7. So from 7 now, that means this will be for 7 will be for a plus b, and this 7 will be h. So that means we need two numbers that add up to 7, and then h is always 7. Okay, h is always 7. Now for us to get a plus b that add up to 7, okay, so and we have already been told that a, b and h can never be 1. So and then we know that a is always less than b. So that means we need two numbers that add up to 7. We have 2, a is equals to 2, for instance. If a is equals to 2, then b will be 5, because that is how we can have 7. So 2 plus 5, 7, and h is always 7. So if you say 2 plus 5, that is 7. 7 times 7, 49. So that means a could either be 2, a could be 2, b will be 5, and h will be 7. Another way around, we can still get another number, another sum that add up to 7. So if a is equals to 3, then b will be equals to 4. You can see that a must always be less than b. So 3 plus 4 meets the criteria because 3 is less than 4, and then they add up to 7, and h will always remain 7. So okay, so is there another one? No, because we cannot have a to be equals to 4 and b to be equals to 3. Why? Because a must always be less than b. So these are the two possible options. A is equals to 2, then b is equals to 5, and h is equals to 7. Or another option would be a is equals to 3, then b is equals to 4, and h is equals to 7. H is always 7. So this is a very interesting question. Okay, so that is how to deal with that question. So the next question is question 25. So we are asked to solve 12 out of 5 minus 2x equals to -3. So what you need to do here is to cross multiply. This one is like over 1. So that means you can have -3 multiplied by the whole of these, 5 minus 2x, then is equals to 12 times 1, which is 12. So we need to open the bracket. So it should be -3 into 5, then -3 into -2x, then equals to 12. If you do this, -3 times 5, that is -15. Minus times minus is plus. 3 times 2x will give us 6x, then is equals to 12. So now what we need to do here, we need to collect like times. Okay, so -15 will come here and it will turn to positive 15. So that means we're going to have 6x to be equals to 12 plus 15. So here we're going to have 6x to be equals to 27. So if you divide both sides by 6, you have 6x over 6 equals to 27 over 6. 6 cancel 6. You have x equals to 3 here, 2 times, 3 here, 9 times. So you have 9 over 2. which is the same thing as 4 whole number 1 over 2. So the value of x is equals to 4 whole number 1 over 2. So you can check your answer. Let's substitute 9 over 2 into the question. So that means you're going to have 12 over 5 minus 2x. That's 2 into 9 over 2. We must get negative 3. Let's see. So 2, we cancel 2 here. So we have 12 over 5 minus 9, which is the same thing as 12 over negative 4, which is the same thing as negative 3. So you can see that our left hand side is equals to the right hand side. So that means we are very correct. So the next one is question 26. A bag contains a large number of colored balls. Each ball is red or green or blue or yellow. A ball is picked at random from the bag. The table shows some of the probabilities. Okay, so here we are asked to calculate the probability that the ball picked is blue or green. So we need to find the probability of blue plus the probability of green. Or means, when you have or, it means addition. So, but the problem here is that we don't know the probability of blue and we don't really know the probability of yellow. So what we're going to do is this. All these probabilities must add up to 1. So that means we can say 0.3 plus 0.1 plus x plus 1.5x must be equals to 1, because all the probabilities must add up to 1. So if we do this now, so this will give us 0.4. If you add these two together, plus 1x plus 1.5x, that will be 2.5x equals to 1. So if you collect like times, 2.5x equals to 1 minus 0.4. You have 2.5x to be equals to 0.6. Now divide both sides by 2.5. Okay, don't forget that calculator is not allowed. So that means x will be equals to 0.6. Let's write it like this, divided by 2.5. So let's write 0.6 as a decimal fraction. That will be 6 over 10. Then divided by 2.5 will be 25 over 10. Then we can now solve this division of fractions. So it will be 6 over 10 times 10 over 25. Then we cancel 10. Then we have x to be equals to 6 over 25. So how do we write 6 over 25 as a decimal number? It's possible. So let's write it here. So we're going to have 6 over 25. So 25 goes in 6 is 0 times. You put decimal point here. You add 0 here. You have 60. 25 goes in 60. That is 2 times. That is 50. So remainder 10. Okay. So 25 goes in 10 is not possible, right? Then we add 0. Then 25 goes in what? In 100 4 times. So that means 6 over 25 is same thing as 0.24. That means x is equals to 0.24. So if x equals to 0.24, then that means the probability of blue ball, so let me write it here, the probability of blue ball will now be 0.24 plus the probability of green ball is 0.1. So by the time you add these two together, so you can write it like this: 0.24 add 0.1. So you must set the decimal point. Here will be 4 plus nothing 4, 2 plus 1 3. Your decimal point must set, then 0. So that means the probability that the ball picked is blue or green is equals to 0.34. So that's the answer, 0.34. So this will be the probability that the picked ball is either blue or green on Thursday. So this will be the end of paper 1 on Thursday.